In order for this home to be green and sustainable, we really want to focus on the outside shell of the home. We chose cement siding for this particular project. Right behind that we have Tyvek drainage wrap. Now the Tyvek drainage wrap lets any moisture that goes through the siding, and no matter how much we try to seal the water out, it'll eventually get through. So the water will hit the Tyvek, drain down behind the siding, let this product be able to dry. And on the inside of that, we have 1 inch of extruded polystyrene, which creates a thermal break on all the wood framework that we have inside the house. So between all of the studs on the inside, we'll have fiberglass insulation that fills the cavity completely. Installation is really key on this. And from that point, all the studs, all the framework on the inside will be covered with CertainTeed membrane, which is a forgivable vapor retarder. That allows any vapor, water vapor that's inside the wall cavity, be able to escape either outside or inside, depending on the time of year and depending on the pressures inside the wall cavity. So what we've done is build a very sustainable, green, long-lasting wall.
The important thing with insulation is to make sure that it's installed perfectly, correctly, with any voids or gaps or places where the insulation isn't in contact with the surfaces that we're insulating. We'll actually start to lose the performance or the R value on that insulation. So things that are important, you can see that the crew has gone through and wherever there's two materials that come together, like wood framing or here around the windows, they've gone through and they've caulked or used some expanding foam to seal those up for air infiltration. In addition to that, some other things that they've done to air seal is where wire holes go in through the top plate and into the attic. This is important because otherwise we would get attic air to come down in through the insulation and into the wall cavity. And that really affects and hurts the performance of the insulation. And with fiberglass insulation, it's very difficult to get the actual rated R value because it's very installer sensitive. And so one of the things that needs to be done is the product needs to be cut and fit inside and behind framing, similar to what you see in this cavity, and also split around wires and pipes and other obstructions in the cavity to make sure that it's not compressed and to not lose any of its R value. Then as you can see over here, what they've done with the insulation is made sure that it completely fills the cavity when they install it so that there are no gaps or voids at the actual framing itself. And they've cut it to fit at the bottom. So what we've done on this cavity is made sure that it's cut to fit exactly inside the framing. And where this is especially important is at the bottom, where it comes down and makes contact with the top plate.
On the inside, you can tell this is an older unit because it has the older version of the NFRC label on it. But this one does have the U factor, has a solar heat gain coefficient. U factor is 0.37, which is kind of high on this particular unit. Solar heat gain's 0.30, and then that's if it's residential. Then they have a different rating if it's non-residential. But when you really want to see this label, if you buy a window that doesn't have that label on it, don't buy it. Because you can, we can go out and make these in our garage if we want, but you have to pay a lot of money to be able to get a manufacturer and have these tested. And this one here is aluminum clad, argon filled, low E. So it tells you exactly what's in this window. The other thing to look at when you're buying these as well is when the window gets taller, make sure that, if it's much taller than this, you'd probably have 2 closures on it. Because sometimes you can buy a window this tall, and if it has 1 closure, then it gets tweaked in the opening sometimes, and then they're not sealed on the exterior. Don't just buy the same window for the whole house. When the person comes out, okay, this direction is obviously east. This one's obviously west. I want the glazing that's for the west. I want the one that's for the east, north, and south. So you may have 4, sometimes even 6 different glazing options for the same house. So let's take a look at the finished product now that they've installed them. You can tell that the carpenters did a really good job of placing the window in the opening correctly. It's square with the opening, and one thing you can really tell when they've taken some extra time is that the window's flush with the drywall on the inside. And for this window to work correctly, it does have to be installed square, and so that there's no leaks around the individual sashes if it's put in a little bit, out of shape, it's not going to work no matter how good of a glazing that you have. You've chosen, just the perfect type of glass. It's made for northern zones. The National Fenestration Rating Council label, states that, and it gives all of our levels as far as solar heat gain and U value. And I think when it's all said and done, this is really going to make a difference having this type of quality window in the home.
When you're choosing fixtures, one of the things you want to look at is water conservation. Things like faucets in the sink, in the bathroom, in the kitchen, shower heads, toilets, anything like that. As far as new construction, you can get low flow fixtures. You can look at the packaging or the information from the manufacturer, and I can tell you how much water they use. Often they're called water sense fixtures. That's a rating that you can rely on as far as water conservation. The other thing you want to remember is when you're using less water, you're also using less energy. Because the hot water you use, you have to spend the time and the energy to heat that. One of the things when you take a look at things such as washing machines and dishwashers is they can get things clean with a lot less water now. Things you want to take a look at is the energy guide, because that rates how much hot water it takes to get things clean and how much water it uses. Same thing with a washing machine. It also is something that will wring more water out of your clothes, and so it takes less energy to dry. One of the things you want to do when you're taking a look at lowering your energy consumption for water heating is to take a look at the system as a whole. You want to look at how the hot water is produced, how it gets to where you use it, and then how you use it. One thing to take a look at is how much water you consume with activities such as clothes washing, bathing, showering. Here's a chart that shows you some of the average uses in a household. For this house, we used a gas water heater. A tank water heater holds the water in a certain temperature until you use it. There's other options we looked at, such as a tankless water heater, which heats the water as you use it, and there's an electric water heater. It would have the same tank as a gas water heater, it's just using electricity for the heat energy. A couple things you want to take in consideration is what kind of energy you have at the site you're working at. Do you have electric power? Do you have gas power? And what's the average utility cost? You also want to make sure that your water heater is efficient. That includes insulation and any kind of controls that could set back the time it starts and stops or how hot it heats the water. In working on the design for this home, one thing we wanted to pay attention to is to make sure the walls that had plumbing in them were stacked or basically very close to each other. If we can line up the water heater and all the fixtures such as the kitchen and the bathroom within close proximity, your hot water doesn't have to travel very far. In this particular home, we had the kitchen right across from the bathroom, and then the bathroom on the main floor was stacked with the bathroom in the basement.
One thing we want to highlight is the high efficiency heating and cooling system that's being installed right now. They've roughed it in, they have the ductwork in place, and I want to show some of the features that we have with a high efficiency furnace and some of the things you may not know about it. One of the first things you'll notice is in this particular area you don't have this big ugly steel flue pipe. This is a sealed combustion furnace, and what that means is it pulls air from outside, it combusts it, and the efficiency is so high that the flue gases go out of plastic pipe because the temperatures are so cool. Instead of having a natural draft furnace where it combusts inside air, it goes out through the plastic. In the natural draft, what happens is you're relying on atmospheric pressures, the flue gases go up. One disadvantage to that is a chance of carbon monoxide. If there's any negative pressures inside the house, like kicking on a bathroom fan or kitchen fan, you could possibly backdraft the gases. So this pretty much eliminates the chance of that. You can tell this is a really quality installation. For one thing, you could tell that they have mastic taped all of the seams, and one of the nicest details on here is you can really see how they've taken extra time and effort to seal these junction points. This is the return air, this is the supply side. So this air is coming from the rest of the house, coming back to the furnace to be heated. So you don't want any air loss. We don't want any duct leakage because then that would affect the design. So everything is sealed. So as the air comes down and goes into the furnace to be reheated, it'll come down into the bottom of the return air. And this is a really nice detail that they've done. Instead of having a square bottom, this angle takes the air and throws it more towards the filter, and so that the air can be cleaned. This is really a nice detail that's just come out in the last few years. A mag seal that goes over the top of the filter, so when you replace or put a new filter in, with the mag seal you can write when you changed it, and obviously you're going to have to add some more lines here because this isn't near enough times, but you can write the date that you changed, keep track of it, put this back on, and this does a very good job of sealing the air out and keeping this tight, plus keeping a good record. This furnace is 93% efficient, so it's very high efficiency. One of the issues with a high efficiency condensing furnace is that you have a condensate that comes out in a small drain hose. You may have seen it in your own home where there's a plastic hose running to a floor drain. In this particular case, in the drain installation, they put it right next to the furnace, so that was right in the design phase. Rather than having a hose run all over the floor, they have it right next to the furnace. And this drain will also be used for the condensate that will be coming for our ventilation system that's going to be installed later.
As we look at electrical consumption in a house, one of the first things we want to implement is homeowner practice. That is a very inexpensive way to reduce energy consumption. And it's as simple as turning out lights, paying attention to what's on, what's off, and even making decisions when you start buying things. Is it something where you really need the in-floor heat? Do you really need all the bells and whistles? A lot of those things are nice to have, but they also consume electricity. Also, things like plug loads. Anything that's got a big transformer that you plug into the wall will consume energy even if the appliance it's plugged into isn't on. There's things that you can use, such as special power strips or putting it on a light switch that will allow you to control those phantom loads. You shouldn't be paying for energy if you're not getting any benefit from it.